Hi everyone, a very good evening and welcome to day 2 of our December daily challenges. If you don't know what I'm talking about, this is what I'm talking about every day. Starting from December 7th, we at Edyst are launching a daily challenge for you with the theme of dynamic programming. Don't worry, don't be afraid about dynamic programming. I'll explain a little bit about it right now. But basically, if you want to participate in these daily challenges, you just need to go and click on this link that's mentioned above. It started on 7th December 2020. Today is day 2. Every day at 6 p.m. this challenge is launched automatically on the Edyst platform, and the solution is released at the same day at 9 p.m. So if you really want to participate in these challenges, try to complete your code or the question for that day before 9 p.m. itself. I think after 9 p.m. everybody will get it because we are releasing the solution. The first person to crack this will be on top of the leaderboard, and it is really ideal for anybody who's either thinking of preparing for product companies, thinks they're already ready, but they should prepare more and so on. These are very similar to the questions asked by product based companies, and the theme this time is dynamic programming. Yeah, I get a lot of memes about dynamic programming. A lot of students say that it's like black magic. It's very difficult to understand and figure out. Well, don't be scared, because in each of these days we are looking up one topic of dynamic programming and simplifying it for you and making it easier for you. Obviously you cannot just learn dynamic programming in a simple 5 days, but our idea is to expose you to as many dynamic programming problems as possible so that you get a feel of these problems and questions. And for more, if you are really interested in this, then you can go ahead and sign up on our advanced algorithms and data structures course. The link is in the description below. It's also mentioned over here. You can click on this link as well. This is a bootcamp that we run specifically for product based companies. I am your instructor over there. We take up previously asked questions of companies like Google, Microsoft, Facebook, and so on. We do monthly assessments, hackathons. We also, for the top performing students, we refer them to product companies. And yeah, and so we have industry awareness sessions as well. So yeah, you can go ahead and sign up on this if you're interested, or reach out to us on the email given below and the WhatsApp number as well if you're interested in the advanced algorithms bootcamp. That was just a small message from our side. As for the December daily challenges, which is what our topic is for today, this is completely free. December daily challenges, you don't really need to pay anything. It's just an exposure activity. You can learn as much about dynamic programming as possible. And today we are going to do day 2, which is the question name is called equal sum. So let's go ahead and check out this question called equal sum on the Edyst platform. Again, the link to sign up is here. If you wanted to check out the link to sign up, you could just check out the link here itself, edyst.com/course-inflow/December daily challenges. It's also in the description below. You can get the link from there as well. Once you click this link, this is what will open up for you. 1 second. This is what is going to open up for you, and yeah, you can just go through and read a lot about this. And when you click the start coding now, you will be asked to sign up, enter your details, and go ahead and start actually writing the code as well. So yeah, we'll go to today's question, which is called so as we said, today's question is called equal sum, and I'll also open up that question. Once you've signed up, you'll get a particular page. Let me just open up the coding question on our platform. Meanwhile, if you have any doubts, questions about the previous ones, do leave them on the chat below, chat on the right side. Our team is online and we'll be happy to respond to you for any questions that you have right now. And you can also leave it in the comments below if you're watching it later and not right away. So you could also leave it in the comments below and we'll reach out to you. Yeah, so just opening up the given question called the equal sums. 1 second. And yeah, sorry for the delay, guys. Here we go. Right. So this is the question. One of the things you'll notice about many of these dynamic programming questions or any advanced question is, generally speaking, the question is not too long. You have very long questions in services based companies because they explain so much of the logic in the questions, not the rule. Like, I think the next question, day 3 question, will be longer than the day 2 question, but this is generally something we've observed, right? Okay, so you're given n numbers, 1 to all the way up until n. So it's like the first n natural numbers you'll be given, and you have to find the number of ways to partition the numbers into 2 sets with equal sum. Those of you who've done DP before will say, yeah, this is very similar to some of the questions we've done previously. Those of you who have not, I'm going to teach you a new technique today, right? So yeah, so basically if you look at something like 7, we have all the possible numbers. So actually let's go ahead and actually look at in our slides what this actually means. So what it's saying is you're supposed to get the first n natural numbers, and let's say if I give you 7, you're supposed to take the first 7 natural numbers, 1 2 3 4 5 6 7, and divide it into 2 equal sets such that the sums are equal, and you need to figure out how many such ways are even possible. Okay, so for example 1 2 3 4 5 6 7, what I could do is, I know that the total sum of this 1 2 3 4 5 6 7 is going to be n into n plus 1 by 2, which is 7 into 8 56 by 2, which is 28. So I need to divide it into 2 equal sets of 14, and you need to figure out how many ways are there of dividing into 2 equal sets of 14. That is what we need to figure out. So for example, if we look at in case of 7 itself, we get that there are 2 equal sets. They need not have the same number, by the way, like the same number of elements, but the sum has to be equal to 14 itself. So if I look at it, I can take 1 3 4 6 on one side, which is nothing but 1 plus 3 4, 4 plus 4 8, 8 plus 6 14, and 2 5 7 on the other side. I could take 1 2 5 6 on the first side, 3 4 7 on another side, 1 2 4 7 on one side, 3 5 6 on another side, 1 6 7 on one side, and 2 3 4 5 in another place. There are no other ways I could take it, but all of these partitions, way of partitioning or way of dividing the elements into different sets will give us an equal set. Okay, and so in this particular case, there's no brute force way of doing this. Like what you could do is you could generate all the particular permutations, which I'm sure a lot of you tried today. You could do that using Python, check out all the particular permutations, but as I've said many times earlier, 99.99% of the times, if you have to use the permutations library, then you've already done something wrong, because permutations is a horrible way of doing something, simply because it's just brute force. It just enumerates all of the permutations and you have to just select one permutation. So if you have got a time limit exceeded today through permutations, know that it is expected. You're not supposed to get the right answer using just permutations. So anyway, apart from just generating the permutations, there isn't really like a brute force solution that you can just apply one for loop, 2 for loops or something. There are a couple of other ways of doing it, but since we want to go for the optimal approach, I don't want to even discuss those. The idea comes from, can I even figure out by looking at an array how many elements are there that sum up to a given target, right? Or how many ways are there that I can sum up to a given target. So here our target is pretty straightforward, that we want to do we want to divide it into 2 equal halves, and therefore to divide into 2 equal halves, it would mean that the sum on both sides is equal. We know that the total sum is n into n plus 1 by 2. That's the sum of the first n natural numbers. So if I want to divide into 2 equal halves, it should be n into n plus 1 by 4 technically, on each side, right? So 56 divided by 4 in this case would be 14, and 14 on both sides is what we should be getting. Let's take another example. Let's take 4 and see whether we can do that, right? So with n is equal to 4, we have to divide 1 2 3 4 into 2 equal sets such that the sums are equal. What is the sum of 1 2 3 4? It is 10. That means we need to divide into 2 equal sets of 5 each. For 4, there is only for 1 2 3 4, there is only 2 ways you could divide 10 into sums of 5 each, right? There is 1 4 on one side and 2 3 on another side. You can't do anything else. You can't really take 1 3 and 2. You would get a number which is 6, and so you'll have 6 on one side, 4 on another side. You can't really do that. So the only way of dividing as 5 5 is this. Okay. Are there ways where we cannot even divide it into 2 equal halves? Before we even start the question, this is a good thing to figure out, right? Are there ways that we can't even divide it into 2 equal parts? Yes, there is. If you look at it, if you take a number like 13. So when you get the sum of the first 13 natural numbers, what will you get? You'll get 13 into 14 divided by 2, which is equal to 91. Now 91 is an odd number. That is the sum of the first natural numbers, that is 1 plus 2 plus 3 all the way up to 13 will actually be an odd sum. If it's an odd sum, I can't really divide into 2 equal parts, right? It's not possible. So this is an edge case where you can't really divide into 2 parts. You'll have to have 0. And we can actually try this out, that we don't even need to go into the deeper question right now. Even if we just are able to write the answer for this particular edge case, we'll pass at least some test cases. I won't say all, and this is just one edge case that we could write, but at least some test case we should be able to pass. For example, if I take n is equal to int input, right? And what I'm going to do is I check that total, that is the total sum that we're going to get, is equal to n into n into n plus 1 divided by 2, right? This is what we're going to get. And what we'll say, no, sorry, double divide. I'm doing it in Python, by the way, because it's very easy to look at a code and understand a code in Python. You could do it in your programming language as well, but I'm not using any function in Python that you would not have in another language. I'm just using very basic arithmetic over here. Anyway, so I got this. And what did we say? If total modulo 2 is not equal to 0, that means it's an odd number, then I can just say print 0, right? I can just do print 0, and I can actually just exit this program here itself, right? So we should probably pass some test cases from this. If I can just run this, I mean, run will not pass because run, I think the input is given as 7. So that's not going to pass for us. But if I just do submit, you do notice that I pass like 2 test cases over here, right? I'm actually passing up 2 test cases because we hit the edge case. So this edge case is actually present in the first 2 test cases. It won't be enough because we need to actually solve the real question as well. But sometimes in some exams, you will get partial marking for some 1 or 2 test cases passed as well. So, you know, always good to even try out the edge case, right? So we got the edge case here that if the sum itself is, or rather the sum itself is odd, then we can't really divide it into 2 parts. So we are assuming that the sum has to be even. In other cases, we'll just print 0 because there are no ways of dividing into 2 parts. So that's one. So now the question boils down to how many ways are there of reaching this particular sum by 2, right? If I have sum of 10, how many ways are there of reaching a sum by 2? Okay. How do we go about doing that? Well, let's look at another more well-defined, or no, I won't say well-defined, a very, very popular problem in dynamic programming called how many ways are there of reaching to a particular sum or reaching a particular sum? How many ways are there? This is a very classic problem in dynamic programming where what we do is we figure out how many ways are there of reaching the sum 1, and then keep introducing a new candidate and see how many new ways are there of reaching other sums. Okay. For example, what we'll do is we'll see that, okay, how many ways, let's say if I give you 1, 2, 3, 4, right? These are the numbers that I have. How many ways are there of reaching the sum 1, right? Well, there is only one way because I have just one number over here, right? What I'll do is I don't really go like by target. I see, okay, I have I'll take the number by number. So I have like 1, 2, 3, 4, right? 1, 2, 3, 4. What I'll do is I'll take 1 first and say, what are all the sums possible with 1? So well, with 1, the sums that are possible are just 1 itself, right? There's no other sum that is possible just using 1. Okay. What are the possibles now that, okay, now I have 1. What are some possible with 1 and 2 itself? Well, whatever were the sums that were possible earlier, they are still possible because you could just take 1 number and add 2 to all of those sums. That 2 is also possible now. So what I mean to say is 1 is now possible. Okay, earlier here 0 was also possible because you could have chosen not to take 1 as well. So both 0 and 1 were possible with 1. Now in this case, earlier 0 was possible. 0 continues to be possible because I could choose not to take 1 and 2. Then what I'll say, okay, 1 again remains to be possible because it, I could choose not to take 2. So 0 and 1 remain possible. But now 2 is also possible and 3 is also possible. Simply what I did, I took the previous numbers and I added 2 to them, because if those previous sums were possible, then my new sums are also possible because now I have a 2 with me, right? Similarly, if I have the candidates, one second. So if I have the candidates as 1, 2, 3, these are the 3 candidates I have. 0, 1, 2, 3 are all still possible. And if I add 3 to it, right, those are the new numbers that are possible. So 3 plus 0, 3, which was earlier possible. Now it is also, it continues to be possible. 3 plus 1, 4 is also now possible. 3 plus 2, 5 is also possible. And since earlier 3 was possible, now 6 is also possible because we will take that earlier 3 and add 3 to it, right? So this way what we're doing is with each increasing number, we are relying on the previous sums that were possible. And we're saying that, you know what, these new sums are possible. This doesn't answer our question. It's just saying that how many, is it possible to reach a sum or not? But our question is not even that. Our question is how many ways are there of reaching a particular sum, right? Not reaching 2, it's reaching a particular sum, right? So how many ways are there of reaching a particular sum? Here we're saying it is possible to reach this sum. So we're not saying how many ways are there. If for those of you who are keenly observing, reaching 3, there are 2 ways. Every other number, there is just one way of reaching it. But reaching 3, there are 2 ways. You could take 3 on its own, or you could take both 1 and 2 on its own, right? Similarly, when we come to 4, there will be 2 ways of reaching 4. Just taking 4 itself or taking 1 and 3 together, right? So we'll have different number of ways. Are these sums possible? Yeah, all of these sums are possible, but we want to know how many ways are there, right? For that, we use an array, and I'll show you the technique we use in that one. What we do is, let's take 4. We know what's the maximum sum possible. The maximum sum possible is 10, because we take all of the numbers together, we'll get 10. And what is that? N into n plus 1 by 2, we get 10. That's the maximum sum possible. And initially we say, let's say I have none of these candidates with me, at least 0 is possible, right? So there is one way of reaching 0, which is by not taking any of the numbers at all. Okay. Now I'll say, okay, let's try to take 1. All right. With 1, and here I'll start from the end. I'll explain at the end why we're starting at the end. I'll go to 10 and say, okay, how many ways were there of reaching 9? Because if there were X number of ways of reaching 9, those many ways are now possible to reach 10 also, because now we got 1. So if there were 10 ways of reaching 9, with just this addition of 1, all of those ways can now reach 10 also, because we added 1 to it. Okay. So here what you'll get is that 10, how many ways were there of reaching 9? There were no ways of reaching 9. So number of ways of reaching 10 is also 0. Same with 9, same with 8, so on. Only this one increases to 1. That is the number of ways there was of reaching 0. Now we have those ways, we just add 1 to it, or we carry over those ways and we get 1 itself over here, right? So the number of ways of reaching 1 is 1 also, because number of ways of reaching 0 was 1, and we can from 0 we can come to 1 directly by just adding 1. So the number of ways doesn't change. The number of ways is same as reaching as 0. Okay, that's a catch over here. Let's go further. Let's say I have 2. Okay, now number of ways, the number of reaching 8 will be the same as number of ways of reaching 10, but it's 0 only here, so we don't see any effect as such, right? Similarly for 9, we will add whatever were the ways of reaching 9 plus whatever are the ways of reaching 7 now, because with 2 I can do that, right? But again, we don't have that. We finally upgrade here. How many ways were there of reaching 1? There was 1 way of reaching 1. So what am I going to do? And there were 0 ways of reaching 3 earlier. So now we have introduced 1 more way of reaching 3. That is number of ways of reaching 1. To all of those ways in which you reached 1, if you just add 2 to it, you're going to reach 3. Since there was only 1 way of reaching 1, now you can actually go and reach 3 as well. Okay. Now with 2, how many ways were there of reaching 0? There was 1 way. So now you can reach 2 as well. Now comes the interesting part. Let's say I come to 3. Okay. Again, I start from the end. For 10, I will check with 7, 9, I'll check with 6, 8, I'll check, so on. We'll keep going until I reach a particular 6 value, right? So earlier there was 1 way of reaching 3. Now I can now reach 6 as well, because with this new 3, all of those ways can now reach 6. Okay, this is one thing. For 5, there was 1 way of reaching 2. Now with this new way, there is 1 way of reaching 5 as well. With 4, there was 1 way of reaching 1. Now I can reach 4 itself. For 3, there was already 1 way of reaching 3, and we are saying from 0 also now you can reach 3. So the previous one plus 1, now it becomes there are 2 ways of reaching 3. For 2, 1, 0, we don't really change anything because 3 won't really affect over there, right? Okay, so we'll just keep going till 3 over here, because after that it's going to go to negative indexes. All right, let's go to 4. Now that we've introduced 4, this is the last candidate we have. For 10, we are saying how many ways were there of reaching 6? There was 1 way. So we say, okay, bring that 1 way here as well. For 9, how many ways were there of reaching 5? Yes, there was 1 way. So we bring that here itself. Ways of reaching 4, there was 1 way. So we bring that 1 here itself. For 7, how many ways were there of reaching 3? There were 2 earlier. So now we bring that 2 here itself. For 6, how many ways were there of reaching 2? There was 1 way. And 6, there was already 1 way of reaching it. So we have 2 over here. Now for 5, there were how many ways of reaching 1? There was 1 way previously, and we already have 1 way of reaching 5. So this becomes 2. For 4, we had 1 way of reaching it, and now we have another way of reaching it from 0. So it becomes 2 over here. So finally, what we can see from this one is for reaching 3, 4, 5, 6, and 7, there are 2 ways of reaching 3, 4, 5, 6, and 7, and that adds up. Like for reaching 3, I can take either 1 and 2, or I can reach by 3 itself. For 4, I can come either by 1 plus 3, or I could just do 4 itself, right? For 5, I could do 2 plus 3, or I could do 1 plus 4, which is what we saw earlier. For 6, I could do 2 plus 4, or I could do 1 plus 2 plus 3. right? So there are two ways of reaching 6. For 7, I could do 3 plus 4, which is 7, or I could do 3 plus 2. What is the other way of reaching 7 itself? The other way of reaching 7 would be 4 plus 1 plus 2, right? 4 plus 1, 5, 5 plus 2, 7. Right? For 8, there is only one way of reaching it. It will be 3 plus 1 plus 4. For 9, it's going to be 2 plus 3 plus 4. And for 10, it's going to be the sum of all of the numbers. So notice that the ways of reaching the final sum is always going to be just one way, because you're going to take sum of all of the numbers, right? So what does this array tell us? This array tells us for each of these numbers, for each of these candidate sums that we can reach to, how many ways are there of reaching. Here, the number of ways of reaching 5 are 2 ways. Therefore, we can only have one pair of sums, right? So if there are 2 ways of reaching 5, you'll keep one pair on one side and another way on another side, right? So and those 2 ways are, as we saw here, one second, we saw here, those are 1, 4 and 2, 3. Those are the only 2 ways. So we have only one pair possible with us. If there are 2 ways, we have one pair. If there are 4 ways, we have 2 possible pairs that we can take, right? So that's what gives us the answer over here, that we have 2 possible pairs of, 2 possible ways of reaching 5. Therefore, we have one pair that is there, one combination of numbers or one combination of partitions that's possible to reach a particular number over here, to reach this particular sum 5. Why are we interested in 5? Because we want to get it to be divided exactly by half, right? That's what we want to do, right? So the total sum is 10. We want to divide it by 2. We get the half over here. Okay. So the approach we'll follow for something like this is create an array of size n into n plus 1 by 2, and the ith index will tell us the ways of reaching the sum I, right? So that's what we'll do. In fact, we will create it as a 1 based indexing. So we'll actually do plus 1 over here, simply because we want to, like, 0 will be there and the last number will also be there. Now what you do is you start an ascending order of all the candidates. For the first candidate, like number 1 you get, try to figure out how you can reach a particular sum I now that this new candidate has come in. So look at the previous ways of reaching I, and with this new candidate, is it an increase in the way of reaching that sum I or not, right? Then go to the desired index. So in this case, it was 5. Generally speaking, it's going to be the total sum divided by 2 is that index we will go to. And at that index, we will find how many ways are there of reaching that particular sum. The last thing that we have not touched upon is that there's a lot of modular arithmetic in this question. If you look at it here, the question does not say give me the answer directly, but it says print the answer modulo 10 raised to 9 plus 7. So this is something I'll come to at the end, because I don't want to confuse you all with the modular arithmetic right away, but I'll just come to it at the end, and I'll just leave you a small note on that part. But this is a standard in most advanced questions where you are actually supposed to do it modulo a big prime number. Okay, so let's take our approach, copy that approach here, and keep that in our pseudocode and actually get started and implement this approach, right? So okay, so create an array of size n into n plus 1 by 2 plus 1, right? So this is the total, this is n into n plus 1 by 2, and this is the edge case that we take, and if this edge case works out, then great, 2 test cases are passed in this case. Otherwise, what we're going to do, right? Otherwise, in that case, what we're going to do is create an array. Let me call that dp. Okay, so dp is equal to 0 into total plus 1. So I created an array of size total plus 1. Each of them has 0, and we know that dp of 0 is equal to 1, right? We know this from the beginning, that dp of 0 is equal to 1. We know that. Okay, next, what are we supposed to do, right? What we're supposed to do is, for each new candidate, so we should start by taking each new candidate. What are all the candidates we have? For I in range, we start from 1, we go all the way up to n. We also include n itself, so we have to do n plus 1, because in Python it goes less than the last number in the range. So we go n plus 1 over here. And what are we going to do? We're going to go from the end of the array like we did. We always started from 10, right? So we are always going to start for j in range. We're going to start at the end, which is total. Till where are we going to go? We'll go till the ith index, right? So in the case of I, we'll go till 1, because 1 is not going to change the way how to reach 0, right? At max, it's going to change the way how to reach 1 itself, but not going to change the way how to reach 0. So we'll go up till 1. Same with 4, we'll go only up till 4. There's no need of going till, let's say, 3, right? Because how will 4 change the number of ways of reaching the sum 3? It's not going to affect it, right? So we'll go till the ith index. To go to the ith index, I have to do I minus 1, because again in Python it's going to be greater than, so it's going to be greater than I minus 1, and I will also do a minus 1. This shows that I am decrementing, okay? And what we're going to say is dp of I, sorry, not dp of I, dp of j is equal to dp of j, whatever the current value you have right now, plus whatever was the value minus the candidate, right? So dp of j minus I. What does this mean? If I'm at 10 and I'm considering the candidate 4, I will check, okay, dp of 10, whatever the value was initially, plus whatever the value at 6, because I want to see, okay, how many ways were there of reaching 6, and now 4 will help me get forward to 10 itself, right? So this is what we have, dp of j is this. Finally, our answer is equal to dp of the total divided by 2, because this will just update the entire dp array, right? We don't really need to do anything more here. And so the midpoint, the total divided by 2 is the midpoint. Those are the number of ways, but that's not the answer, because those are the number of ways of reaching that midpoint sum. What we want to do is divide them by 2 again, because those will be the number of pairs we get, right? So we get answer divided by 2, right? And then we're going to print this particular answer over here, okay? All right, now I'm going to run this, and it's not going to work out exactly. I mean, I can show you as well. It's not going to work out because we didn't really consider modular arithmetic. In this case, for very small inputs, it will work out. But if we go for a large input, we'll get a wrong answer, simply because, so this means that this is a small input, but these are large inputs, and for large inputs, we were supposed to take modulo. We have not taken, so hence it's gone wrong over here, right? Okay. So how does modulo work over here? Because the answer we are supposed to give is modulo. If you are supposed to give an answer by under a modulo, under a big prime number, why do we do a big prime number over here? Simply because sometimes the number can become so big that it may not fit in our normal data types. But the moment we have a big modulo over here, like it says that you have to do print answer modulo 10 raised to 9 plus 7, which is a prime number. Well, if let's say if we had to give the answer modulo 5, let's say we have to give the answer modulo 5, right? Then what do we have to do? The available answers we'll have is 0, 1, 2, 3, 4, right? No matter what calculation you do, you'll get answers here. Basically, if it's modulo n, you'll get only up till modulo n minus 1. This modulo helps us cap the answer in a certain range, and that range will fit in our data type. Generally, that is why we do it. And it's also because the moment you get bigger numbers, computing bigger numbers, it takes a lot of time. So instead what we do is we try to do it modulo some prime number like this one. Okay, great. But how do we, I mean, I could just do print answer modulo that prime, and I'll define that prime over here, right? I could just do this, but again, that won't help us, because intermediately it will start going up, right? Like the number will exceed. Finally, your answer will come down, but the number will exceed the ranges of the integer or the long or whatever you're choosing. So prime is equal to 10 raised to 9 plus 7, right? So instead, what you need to do is apply some principles of modular arithmetic. What are those principles? Well, whenever you are doing any addition or arithmetic, at each of those times also it should be under modulo, right? So for example, if you're doing a sum, so you should take the sum under modulo. So what you'll do is you'll take it modulo prime plus this modulo prime, the whole thing modulo prime. You'll make sure that you do this. This is how a plus b the whole modulo prime is a modulo prime plus b modulo prime the whole thing modulo prime, right? So this is how it works. Similarly for multiplication, if you just change this plus and minus with multiplication, that also works. For division though, that doesn't work like that. So what you got here is you got an answer here, dp total divided by 2. This total will be a decent number. We won't really have any issue with this total, but the problem is that the answer over here is under a modulo, right? Under a modulo of this prime. We can't just divide this by 2. We have to do it under a modulo also. And so to do division under a modulo is not the same as just doing this commutative property of answer modulo prime divided by 2 modulo prime the whole thing modulo prime. That's not the same thing. What you do is you multiply into the modular inverse of 2. So what you're going to do is you're going to multiply into modular inverse of 2 under the the prime modulo, right? And if you don't understand this modular inverse, don't worry, we teach all of this in our advanced bootcamp. I've also covered this in some previous sessions. You can go read it up. It's a very famous concept, modular inverse. So we want to take the modular inverse. Obviously this is not a function as such, but if we take this modular inverse and this is multiplication, so what we'll do is we'll again do modulo prime, and we'll take this modulo inverse also modulo prime, the whole thing modulo prime, right? So that's what we want to do, and we want to take the modular inverse of 2. Now I'm not getting into the nitty-gritty of how to actually find this modular inverse of 2. If you really are interested, the formula is like this. The modular inverse of 2 or any number x raised to minus x raised to minus 1, which is the modular inverse of 2, modulo some p, is equivalent to x raised to m minus 2, x raised to p minus 2 modulo p. This comes from Fermat's theorem and all, and I don't want to get into that, but basically if you did x raised to p minus 2 modulo p, you will get the modular inverse, right? So you can't really just say that, okay, just divide by p modulo. You can't really do that. You need to raise it to this. There's a proof for all of this in modular arithmetic. There's a Fermat's theorem and all of that. If nothing, just remember this thing, right? And now instead of asking Python to calculate it, what I did was I calculated this on the side, like 2 raised to that prime number minus 2 modulo p. I did it on the side, and so the result for that actually comes as this, right? I'll just put that over here. So this is the result for it, right? Because we are sure here we want to divide by 2. If I wanted to divide by some I or some x, then I would have applied this formula. But here we can just hard code the formula itself, because we know that we want to take the modular inverse here itself, right? I'll just put the brackets a little bit better so that we don't have any issue. Okay. All right. So yeah, this is the answer, and now let's print it. So we applied this modular part in 2 places. We actually applied here when we're taking addition, and we did it when we're taking the modular inverse as well as the multiplication part. So now when we run it, will we get the right answer? We get the right answer in run. And if we submit it, we get the right answer here as well, right? So that's how we did this question. Just a quick recap again. There were 2 major concepts that we did here. Number 1 is how to calculate how many ways are there of reaching a particular sum. The way we do that is by taking an array, which for which each index shows us what are the ways in which of reaching that particular index, and we started always from the end. Why did we start from the end, by the way? Why didn't we start from the start? Well, think about it, right? Let's say you started updating, and then to reach 3 there are 2 ways, right? When you finish with 3, and then from 3 you go to 4, and then you'll go to 7 and say that, oh, there are already 2 ways of reaching 3. Let's just add 1 more way right now, right? So that won't work out. Just try it out from doing it from the ascending side instead of the descending side. You will also figure out why it's not working out. That's why we come from the descending side. So that's one. We got this array, but again, this array numbers can become quite big simply because the numbers are very big. Like you could have up till like let's say if you're given 100, so 100 into 101 by 2 would be like what, some 5,000 something, right? So you'll have 5,000 indexes. The number of ways of reaching a 5,000th index is just going to be huge because you're summing up all of these values. So it's going to be a big number. Hence, they've told us to do under modulo. To do under modulo, you have to know addition, subtraction, multiplication, and division under modulo, which is what we briefly covered. But for more, you can sign up on our advanced bootcamp to know about it. So yeah, everybody, that was day 2. That was the day 2 question called equal sum. I hope you liked it. I hope you enjoyed it. If you did, like this video and also subscribe to this channel for more such amazing updates. This is Dynamic Programming Daily Challenges. Wishing you all the best for day 3. I hope to see many more of you participating in day 3. Thank you, everybody. And that's it from our side. I'll see you all on day 3 for another interesting dynamic programming question. Yeah, that's all I'll tell you about that. All right. Thank you, everyone, and see you all next time. Thank you.